Hey Ron, hope you're doing well. It's getting wintry here and the garage is cold, but I finished prepping this crab. This is the crab that Cayman found and I've been prepping, and it's been such a difficult crab to prep. This crab had everything wrong with it. Firstly, there was a big crack going through over here and it actually leached away some of the crab. I don't know if it's dissolved or something. So to kind of reconstruct it going through the middle over here, it was missing part of the stomach there that I had to redo with other bits of crab I had lying around. And it's got a big hole in the stomach. So I don't know if this is actually like a cast. So not an actual crab that died here, but it actually just shed this. Yeah, shed, not a cast. And yeah, the claws aren't too bad except for this weird little thing it's got on here that I left there because I think it's part of it. But yeah, there's also a lot of cracks going through the claw there. And then when I cut it over here to kind of make it into a pedestal, because otherwise it wobbles the whole time, as I cut it over there, it broke apart because that crack was going all the way through the rock. So I had to reconstruct the concretion on the back here. So it's been a bit of a challenge, this one, but yeah, it's done now. I'll give this one to Cayman. So yeah, at least it looks like a crab. You can see this is the stomach of it, and it's got two reasonable claws over there. And we're also going to try and make a 3D model of this large shell that I found. Very large one. And I thought something with a bit of a weird texture are these ripples. So let's see what it does with that one. And Revopoint have sent me a new 3D scanner. So this is the POP 4 3D scanner. They've sent it to me to try out. Apparently it's got a few new features. So let's go make a 3D model of this one. And I've got a large shell I want to do, and I've got some ripples. So we'll put it through a few tests and see what we get out at the end. Well, I've just finished the calibration. It took me a couple of tries to get the calibration to go. You kind of scan these dots in here by holding it at an angle this way and that way. So yeah, don't get discouraged if you don't get it on the first try. Now I've got the crab all set up with some extra light. And the scanner came with this little turntable. So that's just rotating it as the 3D scanner scans it. Let's see what kind of model we get from it. Okay, I've done the scan, and this is the point cloud over here. It's looking pretty good. If you rotate it to the bottom, you can see it's hollow where the carousel was, because obviously the 3D scanner couldn't scan, the bottom part of the model over there, or the fossil. And this is what it looks like fused. There's the hollow part at the bottom. So this is not a 3D model yet, but it's fused the point cloud. And then now this is it meshed. So this is something you can 3D print. It's turned into a 3D print mesh. And very usefully, it's got this fill holes feature over here, which filled in the holes at the bottom. Because to 3D print something, it needs to be watertight. Otherwise the 3D printer is going to have issues trying to print it. But they've got a new feature, which is this 3DGS one over here. And that creates something called a Gaussian splat, which is something new. I had to go read up on it. But this is what they're using in some of the new movies. So like the new Superman movie, his parents were actually these Gaussian splats. And they're actually using it in replays of like NBA and all sorts of other sports, which is really cool. But look at the texture that you get from it. That is really very, very accurate. You can see like all the detail on the claws over there. So this is a lot more accurate for the colors. If you go look at the mesh is obviously taking some of the colors and combining it to create this 3D mesh. And look at that. I'm really liking this 3DGS. This is like a very cool, you can see it's even closed it in at the bottom. So to generate this, it uses machine learning and a few other tricks. But you can now use this in like Unreal Engine 5 and some of those other rendering engines. But that's really cool. I think you can even import it into Blender. So if you're a filmmaker, you probably know a lot more about this than I do. But yeah, that's really cool. And that's a very useful, because when you print this mesh over here, it's obviously in one color on most 3D printers, but if you then have this going along with it, this is my dog getting comfortable on the couch there, but then if you have this one to go along with it, the 3DGS one, you can have a very accurate example of the fossil and see where all the bones are. So when you want to paint it accurately, you can come back to this. Okay, yeah, we've got the model into Blender, which is a 3D program, and you can see it's very detailed. So you can see you can see the shape of the crab much better over here. And if I rotate around it, yeah, that's looking really good. It's nice and watertight, and you can even see where I had to repair the stomach, this little area over here. You can see slightly different texture. Yeah, that's, I'd be really happy with this kind of model if I had to 3D print it. So if you gave me a model like this, I'd be like, yeah, that's a really accurate model. Let's have a look at what the mesh looks like. So if I go into edit mode, it'll load the mesh for us. Very dense mesh. So how many triangles? 2 million triangles. You probably make that a bit less. Yeah, that's looking good. There's no weirdness over here. It has got like a seam going through there, but that won't affect the printing. Let's look at the bottom. So the bottom's the way it had to infill this hole. That's looking good. Yeah, it's a really good model. There's nothing here that you can see where it filled in another hole over here. So these are the holes that it automatically filled in. But yeah, there's nothing here that would worry me. This one will print really well. Okay, there we go. I've just added a better light source, so you can see there is some color to the model. So you can see what's what. Obviously this is not the final render. If you were going to render this with a proper light source and ray tracing, it would look a lot better. Yeah, that's come out well. Let's go try that shell now, because the shell I'm going to have to rotate, which is where previous 3D scanners had issues, because you scan it on the one side and then you have to rotate it, whereas this crab I can just scan, on the one surface, and I didn't have to worry about the bottom because I just closed up that hole. Let's go see how that works. Okay, so here we've got the first scan of the shell. So I've done 3 scans of it. So if I go to the fused data, you can see this is the surface that was facing the top. And it's done a really good job of rendering these little, I don't know, these almost like veins on there, but that's a pyrite growth or something. And obviously the bottom side I'm going to have to scan now, and it looks like it's missed some data over here, so I'm just going to scan this side as well again, and then I'm going to get the software over here to merge it, and let's see how well it does with the merging, because that's quite a complicated procedure. Okay, yeah, I've got the 2 scans. So I've got the top side of the shell and the bottom side of the shell in purple below it, and I'm going to get it to merge it automatically. So let's see what it does. Okay, yeah, it's merged it. Looks to have done quite a good job of it. It's looking pretty good. It's looking promising. You can see it's got some holes over here, so I'm going to merge these 2, and then I'm just going to go scan it again on this side to get that missing data. We could get it to fill in those holes, but it won't be as accurate as scanning it again. Okay, here's the bit I just rescanned. It only took about 2-3 minutes, which is the nice thing with a 3D scanner compared to photogrammetry, because if you've done photogrammetry before, you know it's a long process. Where a 3D scanner like this is much quicker. You can get this done in like half an hour. Okay, so that's the purple one is the 2 I merged previously, and the yellow one is the one I just added now. So let's try and align it. Okay, that's looking pretty good, I think. And now let's export it into Blender and have a look at what the mesh looks like. So generate model. Going to combine those 3 scans now. Okay, here we have it into Blender now. This will tell us what's going on with this, the mesh over here. Let's have a look here. Okay, it's looking good at the top here. I'm gonna have to do some cleanup over here. You can see there's an artifact over here. So this part of here, that's an artifact that needs to be smoothed out. You can see that's sitting on top of the shell. And then also this one over here that will need to get sorted out. And I think this is the seam, so where the top of the shell meets the bottom of the shell, that will have to be smoothed out as well. So you'd have to go into your sculpt mode over here. Okay, so you'd have to come in here and just flatten out these little bits. So you're going to have to come into sculpt mode and just sort out these little bits over here that are sticking out where they shouldn't be sticking out. And then probably change the mesh slightly in the edit mesh mode. So there's usually a bit of cleanup here that you have to do when you're merging models like that, because some noise creeps in. We were lucky with the crab because the crab was only on one, surface, so we didn't have to combine multiple scans into it. But yeah, this model is fine to share with people to print. You can just tidy up those edges over there and a little bit here in the front. Okay, this top part is really good. It's got the shapes that you want in there, and it's got a very accurate size. So someone will be able to identify what species it is from the 3D model, I think. It took me 3 tries to get these ripples scanned, but yeah, it's given a good result. The first 2 times there were some weird overlaps and things happening because, yeah, I think just the ripples they're all very similar, so it was kind of losing its position when it was getting to the actual creating of the mesh. The scan was fine, but the creating of the mesh was having some troubles. But yeah, this is looking good. I can probably upload this to Sketchfab, and some sedimentologists will be able to tell us what direction the current was going when this seabed was being formed, 10 or 12 million years ago. But yeah, that's pretty cool. You can see the ripples really well. I think you can see them better on the computer generated one, because you can see the depth a bit better. Yeah, that's pretty cool. This is much better than the previous version. The previous version couldn't actually scan these ripples. It was getting errors all the time, or just the mesh was looking very messy. But this is looking good. There's no weird overlaps, no weird artifacts on the top here. Only on the edges where it couldn't see, because I was kind of scanning straight down from the top, and that gave me the best result. But yeah, that's cool. I can share that with some researchers, and they'll be able to tell us a bit more about it. This is definitely the easiest 3D scanner I've worked with. It was super solid in the tracking. Previous models, not just from Revopoint, but other manufacturers I've used, they lose their tracking, and that's really irritating. This was so good with keeping the tracking, even with something difficult like this. And if you've got something like these two, where you've got one surface that you can work with, just from one angle, you're going to make a model in 5-10 minutes. When you've got something like this where you have to rotate it and then merge the mesh, there's going to be some cleanup. And I think that'll be with anything you use. Once you're merging meshes, there's going to be some artifacts you have to clean up. So the stats I got from their website is that for the color scans, it's 0.08 millimeters accurate. And if you use the laser scanning, which I didn't, but a lot of people with autoparts use, it's accurate to 0.03 millimeters. And then most of the time I was working at, I think, 0.2 millimeters, because I don't think I need much more than that. That's within the margin of error, if you're going to be measuring things. Just check that your computer can handle it. It does need a pretty beefy computer with a graphics card to do this. It can work with a mobile phone, but I haven't tried that yet, and I'm keen to do that when I'm out in the field, like those crab footprints I found, that's too big to carry back. I'd love to just scan something and then take it back home and 3D print it. Because especially, you know, like bits of sediment like this, oftentimes, you know, it's too big to carry. But then you can just quickly scan it, you know, and then take it home and you have that forever. There was also mention of AI segmentation where it can isolate certain parts of the model, but I didn't try that out. But I did see some other videos of other people trying it out. I'm a geek at heart, so I do love playing with technology and 3D scanners and all those kind of things. And maybe one day I can use these models in a Mam Lambo PC or console game. One day is one day. Yeah, so thanks Revopoint for sending this and also sponsoring the video. Just a little bit of you know, behind the scenes. I do get sent things quite often to test out, and if I'm not happy with it, I send it back because I feel it's not fair showing something that I wouldn't buy myself. But yeah, this is a nifty little device, and I'm really keen to try out that mobile scanning. To try, you know, just taking this, it's not heavy, so you can take this along in field, and they say you can use it for 4 hours on the USB charging thing that comes with it. Yeah, stay safe, and I'll see you on the next hunt.